So first off, I am not 6'4", and the roof is quite larger than 7 foot here. But the 3D printers in the background are real. Welcome to my man cave. Going to start today talking about something a little bit different. We are going to talk today about reliability, especially when it comes to cloud engineering. If I can get my slides to work properly, there we go. So when we do cloud migrations, one of the things that's often left out is what we need to do from a reliability lens to ensure that we are both leveraging the best of what cloud has to offer, but also understanding that that reliability kind of shifts a little bit from an on-prem perspective to a cloud perspective. And there's a lot of little secrets that we'll be going through today to let you figure out how to really leverage the power of the cloud. So first off, start with the very basics. It's not about having a fire. There are fires all the time. It's about how long it burns. I'm here to tell you that AWS, GCC, Azure, any of those, when you're talking about major outages, you're talking about multi-hour events. And these are huge because this is where our multi-region strategy starts coming in. But it also is a realization that your business could be lacking revenue for 3 to 4 hours at a time when you're trying to deal with these outages. And with the reliance on AWS's subsystem services to their other systems, we start seeing a lot of complexity where, for example, when S3 went down, it also took down their status page. So there's a lot of interdependency that can cause problems beyond just that core service. So start talking today about monitoring and compute, which is where a lot of people start when they go to the cloud. They just lift and shift their machines from one place to another. And when we start talking about the virtual servers that are used inside of cloud architecture, we start looking at things like hypervisors and how we bring together the information coming out of these systems. Hypervisors sit on top of the operating system. They sit on top of the CPU. They're actually typically an MCU, microcontroller, very beefy, very powerful, that's able to restrict CPU, networking, allow us to switch those clock cycles out, provide that virtual space and separation. And because they sit outside of this, they're able to give us some information, but not everything. Out of this, you're going to get your CPU and your networking statistics, and those are because we know what CPU and networking are doing at all times with the hypervisor. But because this is a virtual server, and I could literally be running Linux and Windows and whatever across all the different virtual servers on this big piece of hardware, it's impossible for us from a hypervisor standpoint to look at memory usage, which is very different in Linux than it is in Windows. Look at drive space, which can be different from ext4 to NTFS to all the different file systems out there. So we often see the need to run a application inside of the operating system that gives us the ability to see memory and hard drive usage. And oftentimes the cloud provider will provide us with an application we can load inside of our OS that allows us to push that information back to the operating system. There's a couple things to watch out here for, especially when you're talking about things like brew, which can often add a number of phantom drives to your system, if anyone's ever seen that. And also realizing that when it comes to things like AWS, your mounting can be different. So AWS can actually mount drives in, name drive devices differently every time you boot up. So you have to be very careful about how you put monitoring in place, because sometimes, depending on how you leverage the monitoring, saying, hey, I want to look at, /dev/ whatever, that whatever can change from boot to boot, from, stopping your server to starting it. So definitely things to watch out for. And the alternative to the cloud provider system is to leverage something like Datadog or New Relic. I will warn you, these come at a massive price tag, right? So anywhere from $5 to $25 a server is typically what we're seeing in the industry, and that really can impact budgets. One other thing we look at is patching, and I can tell you that I have never seen a good patching system in production that actually was 100% all the time. Never. I would also encourage you to do one very basic thing when it comes to patching. Do not trust patching reporting from anything other than your own system that goes out, looks at what virtual servers you have out there, list all the EC2 devices, right? Then go into each single one of them and query that patching system and make sure they're there. The number of times I've seen systems drop out of patching and not be available, and then not being reported, because if they're not reporting to the patching system doesn't think they're there, so they don't report it as not being patched. So seen some definite misses in that area. We'll go right on to containers. I love containers, right? Who doesn't, right? When we're looking at containers, we have two basic different types in the industry, right? We have that virtual server type container where I'm building, Kubernetes or ECS, or, I'm putting, Docker on an EC2 instance, and I'm sharing that instance out. There becomes a requirement for us to monitor the underlying architecture there, monitoring the CPU, memory, hard drive, network. And then we have to balance our workloads across those. And it can be cost effective, especially for very, very large clusters. But it also brings into account the cost of, I still have to do patching. I still have to do, a number of things from a compliance perspective. If you're in a PCI compliant environment and you're running 10 servers, I don't think it's worth the overhead. Alternative to that is containers as a service. And containers as a service really provides us a way to just get a container and forget about the rest of what the rest of the server is doing. And we just don't care. Hey, here's my container. I don't have to worry about patching or updating. I don't have to worry about who's got access to root or password management routines or anything like that. So it definitely provides us a better overall experience. And here's the thing about monitoring these. If you're using virtual servers, you have to monitor the underlying server. You have to monitor things like cluster balancing. And that's not so important when we're monitoring containers as a service. But either one of these are really areas where you want some visibility inside of the container. And that, can be done with APM. It can be done with a number of different monitoring tools out there. But knowing what's going on as far as memory and CPU and restarts inside of the container, very, very important. Health checks also become very important in containers and can be leveraged a lot differently with some of these, like ECS and some others. They can be leveraged very differently. And especially when you're talking about ECS, make sure to check those timings, because you can literally have a container there that's dead for minutes at a time before it gets recycled. And that can cause you a lot of problems in production. We're talking about impact. Couldn't talk about reliability without impact. And just a very simple truth out there. There's no such thing as 100% uptime. It doesn't exist. And for people who think that you can get there, good luck, my friend. It is very, very expensive to even come close. And remember that when we talk about impact, we're not just talking about uptime, we're talking about revenue. I would rather have an hour of downtime at 3 o'clock in the morning than I would at 3 o'clock in the afternoon. And that really takes that really makes you look differently at what we consider to be the standard metrics of, hey, I want 99.9% uptime. Great. I want 100% uptime between, 6 in the morning and 6 at night when I'm doing my business. And I'm okay with, something else at night. Adding time into that equation really makes it look different. So onto serverless, right? The newest technology out there, the cool stuff, the Lambdas, the serverless JS, the serverless Go, which is my favorite. Serverless architecture, it's going to save the world, right? That's the promise. It's still, it's still running on a core machine. It's still one of those things, and moving to it is great. I've got systems that are entirely serverless. They're running on Lambda, and that's wonderful. You have to, though, monitor those just like you do anything else. You've still got memory there. You've still got processing time. You've still got, an underlying operating system there. CPU is important. And when we start looking at how serverless runs, we can allocate more memory to a serverless, like a Lambda. Also realize when you're allocating more memory, you also allocate more CPU processing power to that Lambda. So things are running slow, you can pop the memory up. You may not need it, but you get that speed as well. So it's a great way for you to understand how to maximize the ability for you to process things very, very quickly. And as we know, latency can be a huge issue in the industry. So as far as processing time goes, that's one thing that in serverless environments, you really have to be careful about, because there are some limits. Lambdas can only run 15 minutes and that's it, you're done. So, understanding when you're timing out, what you're timing out on, understanding what you're running out of memory on, those things are just as important here in serverless as they are anywhere else. And just a reminder here that scaling up is paying up. When you talk about serverless architecture, it's great. When you start talking about running 20 million instances of a Lambda a day, well, I'm sorry, that's when I start looking at containers just from a cost perspective, even if it's a virtual container. Yeah. So behind the scenes, we look at monitoring, and one of the things we can do, Cody was talking about how we come up with infrastructure as code. And I love his discussion about how we, look beyond that, right? So we look at monitoring as code, right? So being able to leverage in the CloudWatch, the Datadog, the New Relic into our infrastructure as code, and be able to build that out as we go along, leveraging things like tagging and such. And that's great. The next level, I think, after that is automation from a standpoint of tagging, being able to actually build out, for example, a Lambda that iterates through your architecture that says, hey, this is an API gateway. I want to know when there's X number of 500 errors, X number of 400 errors. I want to know when I get this information. And automatically having something building out that alerting for you so that no matter what I build out, it's always going to be alerted on, right? That kind of dream moving forward is where I think Datadog and New Relic and any of the monitoring applications out there today, they just miss the mark. The final thoughts, APM, something definitely worth looking at. Just a warning here on APMs. A lot of times exceptions caught by try catches don't show up in APMs, and that's something to definitely be aware of. APMs are great at showing you especially what's happening when you leave the locality of your application, go to database or APIs or whatever. They do a great job in showing you where some of those failures can be. And then finally, we kind of talked about this before, going past monitoring as code and looking at actually building the architecture for your monitoring automagically as you just walk into an environment. I pull out what I need to, I build what I need to, and automatically my alerting and my monitoring just generates itself. And that, I think, is the future of alerting and monitoring. So getting started, just a couple of quick points. Your best bang for your buck when monitoring is going to be going with the native solution that the cloud provider offers. And whether you're rolling that out as something that's completely automated or you're rolling it out as infrastructure as code, is definitely worth looking at. I always prefer, when possible, using serverless or containers, but realize that comes at a cost, right? You lose the cost of upgrades and patching and that, but you also add some other things. For example, think about it. If US East 1 goes down and you're running Lambdas, where can your traffic go? US East 2, US West 1, US West 2. None of those data centers have anywhere near the capacity of US East 1. If US East 1 Lambda ever goes down, it's debatable that there's anywhere in the world that can handle that load. So people who use US East 1 and fail over to the other data centers in AWS, you have to ask yourself, is the capacity going to be there? So start in US West 1, US West 2, US East 2, start there. And then if you need failover capacity, go back to US East 1. So just remember that when you look at serverless, because it's infrastructure on demand, when you have a huge outage, that capacity has to be there and available for you.